Hello everyone, my name is Virendra Singh Rathod. Welcome to my YouTube channel. Or today we are going to talk about another Leetcode problem. So before moving to the problem, please subscribe to my YouTube channel. It motivates me to create better content. And in this series we are specifically talking about the island problems, and I make sure that you are very much familiar with the island problems after watching these all videos from my graph BFS DFS series. So let's talk about today's problem. Number of closed islands. Okay, given a 2D matrix, 0 is a land, 1 is a water and connected 4 directionally. Okay, so we have to identify the closed island. So what do you mean by closed island? So if you see into the example, one is here water. In another problems, one was a land. So be very careful by reading the problem. So one is water. So this is the water. If you see, this one is the water and this 0 is the land. So this 0 0 0, this complete land is surrounded by the water. So that is the reason this is one of the closest island. And if you see here, this is water, all water, and this is 0 is the land which is surrounded by the water. And this is also one of the closed island, but this is not the closed island because this is not surrounded by the water in all the directions. So this is outside. Okay, so this problem looks like surrounded regions problem, which I already talked about. I made a video on that. You can go and watch into my series, the surrounded region videos. It is exactly the similar, little bit more trick. So let's understand how can we solve this problem. So if we see here, this is one, okay, this is water. So here I'll write 1 is water and 0 is land, and we have to find closed island. Okay, and what do you mean by closed island? Means it should be surrounded by all zeros. So basically surrounded by zeros. Okay, and surrounded means all the directions. So basically surrounded by 1, not 0. 0 is already a lane. So surrounded by 1 and all the directions. So basically this should be 0 and all the directions should be 1, no boundary. Okay, boundaries are not considered here. So how can we solve? So first thing what I am thinking is, thought process is coming in my mind is, this 1 is anyways water, but this 0 is a land, but it is not surrounded by the water. So first I will run the DFS on all boundaries as I have done in the surrounded region problem. This boundary, this boundary, this boundary and this boundary, all the boundary, all the rows and columns and the boundaries, and I'll make these zeros to, let's say convert this 0 to some different, let's say convert into 2. And this is also convert into 2, this is also convert into 2. If these zeros are again converted to another 0, then you have to run a DFS and make them also different, like 2. Here also I'll convert into 2. So these are 2 2 2. So now after this is how look like my how it look like now, this matrix. So what I have to do the next blindly I'll just run a loop. Definitely I know there are no zeros on the boundaries now. So I'll go and I'll run these zeros here. You see, I'll run from here, I'll find a 0. Okay, this is the 0. Then I'll run the DFS. My DFS goes like this, and then it will come back and it'll also go like this, So this is complete my. So now here I'll just run a normal DFS and I'll connect all the lands and I'll find, okay, this is connected, so this is 1. And while doing this, definitely I have to again convert these to different, let's say 2, so that I will, or you can mark as a visited, also you can take a visited. So I will make sure I will convert into different, and this is, and this is. So while doing this, now there is no zeros here and I already counted, okay, this is one island, and I am here 100% sure these are closed island because initially I already converted all the boundary elements to different ones. So there is 0. So whichever 0 is there, which is definitely part of a closed island. Now my control comes to here by traversing the matrix. When I come to here, then I see, okay, there is a 0 and this 0 is a closed island. So I'll put it +1, and this is actually alone 0. So I'll convert into 2. Okay, that's all we have to count. So this answer for this is 2. So we'll talk another example. If you see here, what I said, first you run a loop on this boundaries. So okay, on the boundaries, whenever I get a 0, I'll convert into 2. Here it is a 0, convert into 2. Here is a 0, convert into 2. Here is a 0, convert into 2. This is 2, this is 2, and this is also 2. All boundary elements. And boundary elements, and also boundary elements, if it is 0 and connected to a another side again 0, or inside is a 0, then like basically you have to run a DFS and convert all the boundary elements which is connected to 0 to different number. Here I am taking an example of a 2, but you can have any other number also. Now next iteration, what you have to do, you just have to run a blindly and to find a 0. Blindly loop, blindly is okay, I found it is 0. This is definitely a island. So here I will count as a 1 island. Then from this 0, I will see in all the directions, is there any 0? Here there is no 0, so only 1 island. If there are multiple zeros, you have to connect the zeros. If you find again 0, so this answer is 1, and this answer was 2. So if you see the, so you can see here it is 2, and if you see here it is 1. So let's understand the code. Now I already written a code because there is nothing much in this one. So let's see what I am doing is, okay. So here you can see I'm just changing to grid. I'm just getting the length of the grid, and then this is the first row. I am just traversing first row and running this DFS call for the first row. So what I'm doing, if you see the DFS call, I'm just checking the boundaries, and if it is not 0, then I have to return, because I have to go only for the zeros. I have to traverse only for the zeros. So here actually I'm taking -1. In explanation I explained the 2, but doesn't matter that. But it should not be 0 or 1, should be different. That's all. So now I change to -1, and then I'm running 4 directional DFS call, which I already which is written into the question itself. There are 4 directions you have to go: left, top, right, and bottom. So this is for the first row, then this is for the last row, this is for the first column, and this is for the last column. I am doing exactly the same call in all the boundaries to make sure wherever I find a 0, I'll convert into a different number, which is here -1. And then when I go to this is the one where exactly I am going to find the number of closed islands. So if you see here, I am running the DFS whenever I find the first 0. Whenever I met the first 0, so this 0 definitely is not the boundary 0. This is definitely inside. It is definitely part of a closed island. And then I'm running a DFS. I'm increment the count plus, running a DFS, and going from that 0 to all connected zeros, because that will be the 1 island, 1 closed island. And then at the end I'm returning the count. I think that's all in this problem. And when we talk about the time complexity, I am running the DFS. In the worst case, I am doing the call for complete rows, number of rows into number of columns. So the time complexity will be number of rows into number of columns. And as I am not taking any space, so space complexity will be order of 1 if we just ignore the recursive call stack. The another approach for this problem could be, you can use instead of just changing this to -1, you can use another matrix as a boolean visited, and you can put into visited true and false, and based on that you can toggle it however you want. You can do it, but this is also one of the good approach. Okay, thanks for watching the video. Please subscribe to my YouTube channel, and thank you so much. We'll meet into the next another and challenging problem. Thank you so much.